Today, the third unit will be over. Design a suitable compensator for the system whose open loop transfer function is G of S equal to 10 upon S multiplied by S plus 1. So that the compensated system has an undamped natural frequency omega n equal to 3 radians per second and zeta equal to 0.5. First, we should understand the question. The meaning is the pole selected at which we are operating the system should have omega n equal to 3 radians per second and zeta must be 0.5. That is the question. It means we should select the pole at this point whose distance from the origin is 3 radians per second. Already we know that distance from origin to that pole is called omega n, natural frequency. It must be 3, that is given. And zeta equal to 0.5 means cos inverse of 0.5, that is equal to 60 degree. These two are given. Therefore, this pole must be on the root locus. This pole must be on the root locus. And we have to find the k at this point. We have to find the value of k at this point. We have to find. But we have to ensure that root locus is passing through that point. Then only we have to find k there. If it is not passing through that if the root locus is not passing through that point, there is no meaning in finding k at that point. So that's right. We have to ensure that root locus is passing through that point. So let us draw the root locus and check whether this point is on the root locus or not. So the cos inverse of 0.5 is 60 degree means this is constant zeta line, and it is equal to zeta equal to 0.5. That is given. That is 60 degree from negative real axis. So if you draw the root locus for the given system, that is what is given? The given system is 10 upon S multiplied by S plus 1. That is given. But while drawing root locus, we won't take any gain. K will be taken as the gain. We have to vary k from 0 to infinity and draw the root locus, and it should pass through the given point. Let us check what are the poles. Poles are 0, minus 1. The poles are 0. One is at 0, another one at minus 1. This is minus 1. One pole is at 0, another pole at minus 1. Both are starting points. That's why the root locus will approach each other. There will be a breakaway point. How to find a breakaway point? dk by ds equal to 0. K equal to s minus s multiplied by s plus 1. dk by ds equal to what? dk by ds equal to minus s square minus s minus 2s minus 1 equal to 0, or 2s minus 2s equal to plus 1, or s equal to minus 1 by 2. S equal to minus 1 by 2. dk by ds gives s equal to minus 1 by 2. Therefore, the breakaway point is at minus 1 by 2. At minus 1 by 2. The angle of asymptote phi a equal to plus or minus 2q plus 1 multiplied by 180 divided by 2 poles, n equal to 2, m equal to 2, and m equal to 0. Therefore, n minus m equal to 2. If you divide by 2, q equal to 0 means you will get 180 by 2, 90 degree you will get. 90 degree. 3 times 90 degree is 270 degree. One goes at an angle 90 degree. This is 90 degree. Another one goes to infinity at minus 270 degree. Already it is going at that direction. Where is that sigma A? Sigma A equal to sum of real parts of poles, that is minus 1. That's all. Plus 0, minus 0. Sum of real parts of 0 divided by 2. That is equal to minus 1 by 2. Here also the asymptote and the root locus are one over the other. That's why there is no asymptote for second order system. Normally, it will overlap one over the other in second order system. No asymptote, because asymptote is on the root locus. But it is not passing through the point. It is not passing through the point. It is not passing through this point. That is, its length is from 3 from origin, and the angle is minus cos inverse of 0.5, that is 60 degree with the negative real axis. Then what is this angle? This angle is 120 degree, because 180 minus 60 equal to 120 degree. We can represent this point 3 angle 120. 3 angle 120. But the root locus is not passing through that point. That is the problem. We should make the root locus to passing through that point. Then we have to find the value of k at that point. So 3 angle 120 is in polar coordinate, rectangular coordinate. What is the rectangular coordinate? 3 angle 120. If you convert this into rectangular coordinate, you will get 181 minus 1.5 plus or minus j 1.5. Use your calci. Shift polar. Shift rectangular. REC. Shift rectangular. What are the parameters? 3, 120 you have to pass. Minus 1.5. The answer we got immediately. The real part we got. The real part we got immediately. No need to do all these calculations. Immediately you got minus 1.5. Real part. Imaginary part, in my calci, press RCL F. If you press that, 2.59, that is 2.6. That is equal to minus 1.5 plus or minus j 2.6. This is the point. Therefore, the coordinate here is minus 1.5 plus j 2.6. Here, what is the coordinate? Here, minus 1.5 minus j 2.6. But root locus is not passing through that point. That is the problem here. So we have to make the root locus passing through that point. Suppose if the root locus is passing through that point, what is the angle? 180 degree. What is the angle? If the point is passing through that point P, if it is passing through that point P, the net angle contribution at that point is 180 degree. That we know. From that point, if you draw lines to all poles, and if you add, it will be an odd multiple of 180 degree. But it is not passing through that. Definitely there will be a angle deficiency. What is that angle deficiency? What is that point? Point is this minus 1.5 plus j 2.6 is the point. But root locus is passing through this. Root locus is passing through this. This is the root locus. Root locus is passing through like this. One goes to minus j infinity, another goes to plus j infinity. Plus j infinity. But it is not passing through that point P. P is plus minus 1.5 plus j 2.6. So to make the root locus passing through that point, we have to find the angle of deficiency. Angle of deficiency phi equal to 180 minus 180, or we have to get positive angle. That's why plus or minus 180, 2q plus 1 plus the angle made by angle deficiency means we have to subtract. Let us subtract. Minus the angle of g of minus 1.5 plus j 2.6. Angle of that is equal to plus or minus 180 2q plus 1 minus, what is the angle made by this? This angle is already available. The remaining angle we have to find at this point. What is the balance angle that we have to find? So we have to substitute in G. What you will get? K as such you will get. Angle of K as such you will get. In place of S, we have to substitute minus 1.5 plus J 2.6. In place of S plus 1, what is the transfer function? K divided by S multiplied by S plus 1. In place of S plus 1, we have to substitute minus 1.5 plus J 2.6 plus 1. So for that, we have to find the angle. For that, we have to find the angle. Angle of this can be written as plus or minus 180 degree 2q plus 1 minus of minus angle of minus 1.5 plus J 2.6 minus of angle of minus 1.5 plus 1 equal to minus 0.5 plus J 2.6. These two angles we have to find. That's all. The simplest way is if you enter, in other words, the angle is, this is theta 1, this is theta 2, this is theta 2. These two angles we have to find, theta 1, theta 2. You have to use your mind to find. Instead, just you can use the calci to find the angle. So what we have to use? Shift, enter in your calci, polar, shift polar, minus 1.5, comma, 2.6. If you call that, you will get the length from there. That is 3. The length is 3. Already we know. Already omega n equal to 3, it is given. Then press in my calci, press RCL F. The angle is 119.9. 119.9. Therefore, the angle of deficiency equal to plus or minus 180, 2q plus 1, 2q plus 1 minus, why minus this minus? This minus is because of denominator. Minus, the answer is plus 119.9. Let us put 120 degree. Minus 120 degree. That is also correct. We know. Because from origin we draw a line up to P, the angle is 120 degree, that we know. That is, it is correctly giving. So then again, we have to find the angle for this. Again, enter, shift, polar, minus 0.5, comma, 2.6. The length is 2.6. The length is 2.6. P to that point, the length is 2.6. That is line between, this is 2.6. The angle theta 2 equal to, length is not required, angle is required. Press RCL F. In your calci, it may be different. 100.88. Let us say 100.1. 101. Say 101 degree. Therefore, minus 180 plus 120 plus 101 equal to 221. Equal to how much? Equal to 41 degree. 41 degree. So the angle of deficiency is 41 degree. Now we can find the compensatory system. To find the compensatory system, we have to use this 41 degree so that the angle deficiency at P equal to 0. So net angle at this point will be odd multiple of 180. For that, we have to use this deficiency angle 41 degree to find a subsystem. That subsystem is G compensatory system in series with the original system is Kc multiplied by S plus Z1 divided by S plus P1. Now we have to find that Z1 and P1. If you cascade this system with the original system, the root locus will pass through P. If you cascade this system, this compensatory system with the original system, If you cascade like that, then the root locus will pass through that. Now we have to find Z1 and P1. To find Z1 and P1, what we have to do is draw a horizontal line at P. That is PA we have to draw. PA. Draw a horizontal line at P. Then divide that angle. Divide that angle. How to divide? Draw an arc from this point. Draw one arc from here. Draw one arc. You will get this point, so that if you join that, you are divided the angle OPA. Divide the angle OPA. Once you divided, take an angle of 20.5 here and 20.5 here, because total angle is 41 degree. Deficiency is 41 degree. Draw 20.5 degree this side, the right side of PB, and take 20.5 degree on the left hand side. Draw the line at an angle 20.5. 20.5. Draw a line at 20.5. Draw another line at 20.5. It cuts at minus 1.85. The angle is taken 26 degree actually wrongly, but it should be 21 degree. But anyhow, let us take that approximate value. Approximately it met at 1.85, and here it meet at 3.95. At 3.95, if you actually draw, you can find the exact point. So minus 1.85, the poles are minus 1.85 and minus 3.95. The zero is Z1 equal to minus 1.85, and the compensatory system pole is minus 3.95. That V2 we got. Now we have to draw again the root locus. What is the compensatory system? The compensatory system is R of S. The compensatory system here is Kc S plus 1.85 upon S plus 3.95. We got the compensatory system. What is the original system? Original system is 10 upon S multiplied by S plus 1. Now, we want to modify the behavior of that original system. That's why we cascaded this new system. This is called the compensatory system. Compensatory system is added, cascaded to the original system. Now we have to draw again the root locus. Whether it pass through P or not, we have to check. For that, again, we won't take Kc, and this 10 will be assumed as K. Therefore, the open loop transfer function, compensated open loop transfer function, modified compensate open loop transfer function is K upon K multiplied by S plus 1.85 upon S multiplied by S plus 1 multiplied by S plus 3.95. This is the open loop system. For this, we have to draw the root locus and check whether it is passing through P or not. So for that, what are the poles? Poles are at 0, minus 1, then minus 3.95. These are the poles. This pole is additionally added to modify the characteristics of the system. Zeros are minus 1.85. Zeros are at minus 1.85. Now we have to draw the root locus. Before that, let us find n minus m equal to what? N minus m equal to 3 minus 1. That is n minus m equal to 3 minus 1 equal to 2 again. Therefore, the angle of asymptotes are 2 will end at infinity. Out of 3 root locus, how many root locus branches? 3 root locus branches. Out of 3 root locus branches, 2 will end at infinity. Therefore, plus or minus 2q plus 1 multiplied by 180 divided by n minus m is 2, where q equal to 0, 1. If you substitute 0, you will get 90 degree, and another one is 270 degree. What is sigma A? Sigma A equal to sum of real parts of poles. that is -1 minus 3.95 minus 0. 0 is what? Sum of real parts of 0 is equal to minus 1.85 whole divided by 2. That is minus 3 by 2. That is minus 1.5. Minus 1.5. Minus 1.5. Minus 1.5. Therefore, we can draw the root locus. What is that root locus? One pole is at 0. The poles are one pole at 0, another pole at -1, another pole at minus 3.95. One pole at another pole at -1, and this is -2, -3, -4. Another pole is at minus 3.95. Now, the angle of asymptotes. Before that, we have to find the root locus on the real axis. That is, both are starting points. 0 and -1 are starting points. Therefore, root locus will be like this. There will be a breakaway point. And now we have to draw the breakaway point. Now let us find the breakaway point. To find the breakaway point, k equal to what? K equal to minus s multiplied by s plus 1 multiplied by s plus 3.95 divided by s plus 1.85. dk by ds equal to what? Dk by ds equal to s plus 1 s plus 3.85 whole square s plus 3.85 whole square. Derivative of numerator. What is numerator? The numerator polynomial is s square plus 4.95 s plus 3.95 s square s cube. This is the numerator polynomial. 9.9 s 9.9 s plus 3.95 minus, we have to write as such s plus 3.95 multiplied by 1. Sorry, we have to write s cube plus 4.95 s square 3.95 s multiplied by 1. You have to equate this to 0. dk by ds equate to 0. This implies numerator is 0. What is numerator? S plus 3.95 multiplied by 3s square plus 9.9 s plus 3.95 minus s cube plus 4.95 s square plus 3.95 s equal to 0. What are the roots? The roots is minus 0.5 minus 2.8 minus 2.8 and minus 2.8 plus jx and minus jx. So these two are complex poles. Therefore, minus 2.5 minus 0.5 is the minus 0.5 is the breakaway point. The breakaway point is minus 0.5. This is the breakaway point, minus 0.5. Minus 0.5. Now we have to find what is sigma a? Sigma 1.5. Therefore, we have to draw an asymptote at 1.5. This is asymptote. That is sigma a. Sigma a equal to minus 1.5. Angle equal to 90. One is 90, another one is 270. the pole is 1.5, the P is at 1.5 minus 1.5 and plus J 2.6. This point is J 2.6. So this is P. P is here. The asymptote and P are one over the other. So now we have to draw the root locus for this asymptote. Definitely it will bend and it will pass through this. And it will bend and pass through this. So now we modified the root locus so that it is passing through P. It is modified the root locus. It is passing through P. Now we have to find what is the compensatory system? Kc multiplied by S plus Z1 divided by S plus P1. Z1, P1 graphically we found. Only thing is we have to find Kc. Here, in this case, 10 is there, Kc is there. Together it is called K. K equal to 10 Kc. Now we have to find K. Once you find K, you can find Kc. To find K, we have to draw a line from P to all poles and zeros. The line from P to one pole, another pole, another pole, one more zero at a minus 1.85. Here, one zero is there. Zero is there. For that also you have to draw a line. Now we have to find the length. What is the length of this P0? The length is modulus of P0. What is the length of this? Let us call this as P1, P2, P3, and Z1. The length of this is P1. Length of this is modulus of P2. Length of this is PZ1. Length of this is P3. If you know all this length, we can find the magnitude. We can find the magnitude. Therefore, K equal to PP1 multiplied by PP2 multiplied by PP3 divided by PZ1. This is the K, required K, because we do not know the value of K at the root locus is for K equal to 0 to K equal to infinity. But we do not know the value at P, value of K at P, that we are going to find. For that we joined PP1, PP2, PP3 and PZ1. Now we have to find the length. This is analytically you can find or you can measure by using scale, because the graph sheet is 1 division equal to 1 centimeter. In both x-axis and y-axis, you should take like that. Then you can directly measure by using scale. Otherwise, you can analytically find what is that length. P is what? P is minus 1.5 plus J 2.6. That is P. Through that, the root locus now passing. What is P1? We have to subtract that P1. P1 is 0 in this case. 0. What is P2? Minus 1.5 plus J 2.6 minus P2 is minus 1. What is PP3? Minus 1.5 plus J 2.6 minus 3.95 whole divided by modulus of minus 1.5 plus J 2.6 minus of the length we have to find, minus of minus 1.85. That's all, because that is 0. That gives K. That gives K. This you can find simply by using calci, by calling the polar function. So first let us write the minus 1.5 plus J 2.6 multiplied by minus 1.5 minus 1.5 plus 1 equal to minus 0.5 minus 0.5 plus J 2.6 minus 1.5 plus 4.95 minus 1.5 is 2.5. So 2.45 plus 2.45 plus J 2.6 whole divided by 1.85 minus 1.5 is 3.35. 0.35 plus J 2.6. These are all we have to find the length. So we can use your calci, take your calci, call polar. The first value is minus 1.5, comma 2.6. Magnitude is required, that is 3. Already we know. Already one time we found. Shift again. Polar minus 0.5, minus 0.5, comma. Second value is 2.6. We have to call that first value is required 2.647. Therefore, 2.647. 647. Let us take 6. The third value is we have to call again. Shift polar 2.45, comma 2.6 equal. After entering the values, you have to enter equal 3.57. 3.572. Therefore, we can take 3.57 divided by, what is the value? Is 0.35, comma 2.6. Again, shift polar function 0.35, comma 2.6 equals 2.663. 2.6. That is equal to 2.6 getting cancelled. 3 multiplied by 3.57 equal to 10.71. 10.71. The K value is 10.71. But we know that KC equal, 10 Kc equal to 10.71. Therefore, Kc equal to 10.71 divided by 10. That is 1.07. 1.07 is the Kc value. Therefore, the compensatory system, what is that compensatory system? We found GC, the compensatory system equal to Kc multiplied by S plus Z1 divided by S plus P1. We do not know the value of Kc. That also we now found. Therefore, the compensatory system GC of S equal to Kc we found 1.07 multiplied by S plus 1.85 divided by S plus 3.95. That is the compensatory system. If we include this in series with the original system, your root locus is modified and you will get the desired characteristics. It's omega n equal to 3. It's zeta equal to 0.5. Zeta equal to 0.5 you will get. This is the compensatory system. This is the answer. But it is not sufficient. We have to find that sometimes in the examination, they may ask, what is the circuit elements? Sometimes they may ask, what is the circuit for this lead network? The circuit for this lead network is, this is V in R1, C1, R2, and C2. This will be inverted. That's why we would put one more inverter. Otherwise, we can adjust here itself. So, a resistor here, R3 and R4. This is the circuit. Sometimes they may ask, find the circuit elements. We know that the mathematical model of this is V0 by V in equal to V0 multiplied by S plus 1 by R1 C1 whole divided by S plus 1 by R2 C2. So we have to find the resistances. Let us assume that C1 equal to C2 equal to 10 microfarad. That is equal to 10 into 10 power minus 6 farad. Now R1C1 equal to R1C1. 1 by R1C1 equal to 1.85. But C1 you know, therefore you can find R1. Similarly, 1 by R2C2 equal to 3.95. And C2 is 10 microfarad. Therefore, R2 also you can find. Let us check whether the root locus is modified or not. Now, what is the compensatory system? Compensated system. What is the compensated system? The compensated system is this multiplied by 1.07 multiplied by S plus 1.85 whole divided by S plus 3.95 multiplied by 10 S multiplied by S plus 1. This is the compensated system. For that, we have to draw the root locus in MATLAB and check whether it is passing through. Here already we manually drawn an approximate plot. So let us check in MATLAB whether it is passing through that or not. For that, let us, what is the transfer function? S plus, we have to assume 10 multiplied by k is equal to k. K multiplied by S plus 1.85. Numerator polynomial we know. What is the denominator polynomial? The denominator polynomial also we know that here we found yes, S cube plus S cube plus 4.95 S square, S cube plus 4.95 S square plus 3.95 S plus K. This is the closed loop transfer function. Open loop transfer function means this K will not appear. Therefore, what is the denominator polynomial? Denominator polynomial is S cube plus 4.95 S square plus 3.95 S plus 0. Constant term is 0. What is numerator polynomial? Numerator polynomial is S plus 1.85. That's all. Now let us check in MATLAB. So what is numerator polynomial? Numerator polynomial is 1.85. That is numerator polynomial. What is denominator polynomial? Denominator polynomial is, what is S cube coefficient? 1. Then S square coefficient 4.95. Then S coefficient 3.95. Constant term is 0. So now we have to form the so it will be stored in the variable called answer. So we can, root locus can be drawn by calling that function R locus answer. So this is the root locus. It is, now we have to find the value of k at minus 1.5 comma 2.6. R log find k equal. Now you will get a okay, we will find 1.5 and around 2.6. It is not exactly passing through at 2.6, but 2.6, you know, this is 3, 2.6 is around here. It is not passing, it comes very close to that because we didn't draw that graph correctly. So at this point, what is the value of k you will get? Here, what is the value you got? 12.15. Analytically, how much we got? 10 point something. because it is not exactly passing through that point. That's why the difference 12.1579. So in MATLAB, you can directly find the value of K by selecting RLOC find. Any point, you select that point, you can find the K. Suppose if you want to find R here, it will be less than that. We'll check whether that R value is, K value is less than 12.56. Let us check. Here it must be less than 12 point something. What is that? 6.4. It is less than 12 point something. That we can find.